Okay. So I have a very big problem.
Ha, Omo,
Very
that
big one.
what kind of problem?
Okay, I did not want to let you know in chat. So I've not done my task. My laptop got faulty for the past 2 weeks, so I've not been able to fix it, and I'm really, really feeling bad that I've not been able to do tasks, and I'm not sure of meeting up the last task.
Can you get a laptop to do the last? But you have not done tax 6, right?
I've done my, I think task 6 is the one remaining. The last one that you gave, that's the one I've not yet done.
That's tax. The one I told you to deploy a VPC, with normal clicking
Yeah,
on the console.
VPC.
No, I don't know how to solve that problem for you. I
Sure.
just feel like it's
And then
possible that you can just you know, get a laptop
getting a
and
laptop with
just, yeah, and just
downloading it and all Docker
yeah.
stuff. That's it. My laptop had screen
Or you can
issue.
just borrow a
Even
laptop from a dev now, from a from a developer that you can trust.
yeah, I think
That
I will
already
take
has
for that.
all those setups already.
I think I'll ask of that.
Please, because you're one of the serious.
No
You're
problem. So
one of the.
anyhow, I'll let you.
All right, no problem. Um. So yeah, this is our Terraform code. This is a Terraform code. Um, what we're going to do today is going to talk about the anatomy of a Terraform code, and all the inner workings of the Terraform code. Please confirm you can hear me.
You're loud and clear.
All right. Thank you very much for that confirmation. So this is a Terraform code. And from here now we can see under this is the Dream Vacation app. So I'm literally giving like a scope of how your projects would look like. How your projects will look like. So under this Dream Vacation app, there's backend, there's front, and then there's Terraform. You get. So there's Terraform and we'll move it here. So this is main.tf. So main.tf contains the point where you actually write the resource that you're actually trying to create. That's where your main.tf will reside in. Then there is the output.tf. The output.tf gives you the output that you should be expecting when the resource it has been created. For example, we are working with a we're working with an EC2 instance. When you create an EC2 instance, what do you expect? You expect the public IP, you expect the private IP, you expect the public DNS, you expect the key name. You understand that it's supposed to come out of it. So that's what we're expecting. So after this thing has been created, you expect the public IP. So the public IP should appear, the public DNS should appear, the value should appear, the security group ID, the key pair name. So this we're using the same key pair that we created in the last class. And then SSH command used to enter it should appear. Or you can just, copy it and put on your terminal or something. So first of all, like I said, to get Terraform, you have to install AWS CLI. You have to install AWS credentials, and then you have to check that's by the way. So you have to ensure that your AWS is installed on your local machine using the AWS CLI, because Terraform works with the AWS CLI inside your computer. Terraform works with the AWS CLI inside your computer to be able to get the information on the account that it should deploy to. You understand? So that's how Terraform works. So now, if you check in this one now to confirm if your account has been successfully uh merged, you do AWS STS get caller identity. This caller identity now is the IAM configuration that's attached to your AWS CLI, which is this. You can see this is my AWS account. This is my AWS account ID. Then look at the user Ezekiel. I've created it. I've created it here. So yeah, I've attached it to this. So that's why I did AWS STS. If you do AWS STS, get caller identity, and it doesn't show this, know that, or throws you an error, know that your CLI is not properly attached to your local machine. So you have to ensure that this works. You already know how to create an IAM, user on AWS. Yeah. So first things first, one thing with Terraform, there's also the provider what? The provider dot tf. Now this provider is where you would configure the provider. Basically, since it's AWS, you configure AWS as the provider. Then there is required providers, AWS. So this code now goes to HashiCorp. So HashiCorp is what manages the Terraform providers for Terraform basically. So it's going to do going to get the source. The source is HashiCorp AWS. If you're using Azure, here will be Azure. Here will be Azure. If you're any of them, but since you're using AWS, it just be AWS. Then you can see now this version. This version simply means anything greater than 5.0. That means 5.0 is, so it's just like this, just like anything greater than 5.0. So that means 5.0 is the minimum version that should be allowed to deploy this. In production, this may not be ideal because you don't want you won't want some version that will probably come and break the infrastructure code. So you have to put like a solid version, like it's 5.4, 5.40, or 5. This one too also has its own advantages because you won't need to always be upgrading dependencies. You understand? Whenever a new engineer comes and wants to, clone the repo and do all this sort of, it automatically does it in the new one. So it depends on what your team wants, basically. And this is required version. The required version is the version of Terraform that you should go and collect. This one is the version of AWS. This is the version of AWS under here. So this required version, that means for this code base to work, your Terraform should be running a version that is greater than 1.0. That's what required version simply is. So let me see if we can check it here. Terraform. Oh boy. Yep, you can see it. You can see it. Your version of Terraform, oh, even telling me it's out of date. What's my own? 12.2. It's not even very, very, very distinct, Seth. It's not even very, 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 very away. My own is Terraform Vish version 1.2, 1.12.2. So that's what it is. Provider. So this is the provider that's already installed in the laptop. When I did this, is the version 5.100.0, which is greater than 5.0 that we specified in required version. That means if you are running this infrastructure on a Terraform version that is less than 1.0, let's just say 0.9, it should flag it. It's going to flag it as an error on your terminal. You get. Now this provider is telling you provider AWS. So this provider comes with when you have already extracted AWS here. To now tell you provider AWS. And then region. Your region is var.aws. Now this var now is going to pick the region from variables.tf, which is here, which is, you can see, US East 1. So it's going to look for aws.region in this variable and then default to US East. So that means, this simply means that anything you are deploying in this infrastructure must be in the US East 1 region. So that's what. So that's it for the provider. There are a lot. You can also add a backend here that will, you can add like a backend for S3, but we're not doing that stuff because that's more advanced and stuff. You can add a backend here so that you store your Terraform state. Now, once you have done this Terraform, once I've done this, once I've put the provider, you go and do Terraform init. Note that navigate to where the Terraform is and then do Terraform init. You can see initializing the backend. The reason why it's taking time because I made some changes and I put it back. But you see, initializing the backend going to take time reusing previous version because I've already done Terraform init before, so I didn't change the version. If I change this now to probably another thing, now to go and start getting the new version again. So this Terraform init legit goes and picks out. This is what downloads all these specifications that we have put in this provider.tf. It will go and download it, and then it will now do Terraform has been successfully initialized. You may now begin working with Terraform. Kini. Now, once you have done that, you will see a Terraform folder will be created for you inside your code base, and then Terraform log. Note that do not push this Terraform log inside your repo. So the best thing to do is to go to your git ignore and push it because it's already here. Terraform lock, it's already here. That's why it's marked out black because it's not going to go to your repo. Yeah. Now, first things first is the main. You can see the main. What are we doing? We are going to get the default. We are going to get the default VPC. So we are going to use data. What did I say in the last class? You use data when Use data when the resource already exists. Let me open my AWS. Can you see my AWS? You use that one when you use data when the resource already exists in the AWS infrastructure. You just want to call it into the application. Now, let me show you the default VPC. By the way, tomorrow is my birthday, so people should know what you're going to do for me tomorrow. Just want to throw it out there. I'm on vacation. I use the word vacation. I'm on leave, so I went back home. I went back to my parents' house to get and rest because that's the only way I know I can eat free food. Yes, thank you very much. So yeah. Now you can see this one now, default VPC. You can see this one is tagged default VPC, and you can see default, yes, because it's the default VPC. Now, if you come here now, it's going to look for where the default is here and pick it. Default equal to true. When it will go and look for the VPC where the default is true. Like you saw in the last thing when I just showed you my AWS, the one that wrote default, yes, it's going to pick it. Now, the default subnet, because I'm using default subnet, in your tags, you're not going to use default, you're going to create a VPC, which is the same thing that we are creating here. Let me look for the, I think I'm going to post this. Someone should, when I drop the AWS doc, someone should post it on the Discord channel so that, because one thing about Terraform is that you don't need to break your head too much to think about a lot of logic. Most of the resources you want to deploy, they have like a documentation for it. So what you just need to do is, go and find the documentation relevant to your provider and work with it, to get. I'm coming. I'm looking for Terraform documentation for AWS, so I'll paste it on the group so that most people will not have issues. Yeah, AWS provider. People won't have issues, in terms of building your own stuff because you can legit build anything. I'm sure most of you have seen the new tags I dropped. Anything you want to build, you want to deploy with code, you can deploy it. So I'm pasting it on the group. Please, someone should paste it on Discord, please. Someone should do me a favor, paste this on Discord. I'll be watching my Discord to see someone has pasted it. Paste these docs on Discord so that when you need to build your own stuff, you build it. Now, okay, let's go back to where we were. So this is it. Now, we are default true. Subnet, we're going to also use the default subnet as well. Now, the name of the, it's going to find where there's the VPC ID and then the value. So this value now is trying to pick out the default, the ID of the default VPC that we have created here. So you can see it's data.aws VPC. Now this default is a name. It's not like it's a default. It's the name of this resource we are creating here. So the name is default. You can just name it default underscore VPC, but we'll leave it as default. So it's going to say AWS. Now, this AWS VPC now is the resource that we are creating. So we're creating, and now that's why I also say you should have to go and read the docs as well. because the docs will provide you. Let me even share my screen so you can see the docs. You can see the docs properly. Okay, please confirm you can see the docs. I'm sure you can see it. Now this is AWS documentation for Terraform. You get this is AWS documentation for Terraform. Now there are a lot. You can see all the resources: ACM, API Gateway, Amplify, Athena, Backup. Every AWS resource: CloudMap, Cloud9, Cloud3, CloudWatch. Part of your task involves CloudWatch, so you have to come and pick it up here. Code build, Cognito, Config, Control Tower, DSSQL, DevOps Guru, DynamoDB, EBS, EC2, all of them, every single resource you want is here. Now it's giving us example usage. This is what I've sent you before. Provider. This one is less than 6.0. Provider is this. Now, this resource, this name you are seeing here, AWS VPC, is the name of the VPC. So it's like you're telling you to create a VPC. You understand? That's why it's AWS VPC. If you go down to VPC, Virtual Private Cloud, you can see default VPC here. I'm going to tell you default VPC. So you can see default VPC or AWS default VPC. Or if you don't want to create AWS default VPC, you can just do it. So this particular one goes and picks up the default VPC, or you go and use the default equals to true. So you can see AWS VPC here. AWS VPC. This is AWS VPC now. You name it. So this one is main. Then you put the cider block and all those other ones. So there are a lot. Depending on all the demand for what you want to do. So the reason why we are using data is because data is what helps us to pull out, an already existing resource. But that's by the way. So to make this documentation your friend, and you would enjoy infrastructure as code, basically. So moving on. Now you're going to create security groups. Security groups is supposed to allow traffic into your infrastructure or allow access to your infrastructure. Now you can see AWS security group. Now I'm naming this EC2SG. The name is this. The VPC ID is now it's going to, when you say VPC ID, it's going to go to data.awsvpc.default.id. So it's going to come here, look for it, and then .id to the ID of whatever is gotten from here. That's what it's going to put here. Now, inside the security group, there is when you're creating a security group, there is inbound row and outbound row. So ingress, that's why I always mention, that's why I ensure that I taught the manual, provisioning before I taught the what they call it, before I taught Terraform, because it won't make sense if you understand how to do it manually, but you don't understand how to do it automatically. Sorry, you understand how to do it automatically, but you don't understand how to do it manually. Yeah. So ingress. Ingress is for inbound rules. So if you go to your let me even do it now because I'm connecting the dots while I'm teaching. So if you go here now, you'll see security groups. Security groups. Yeah, so you can see inbound rules. The inbound rules is allowing SSH to enter from anywhere in the internet. It's allowing HTTP and it's also allowing HTTPS. That's for inbound rules. But for outbound rules, okay, they are not out. Okay, outbound rules only allowing 000 from all traffic. So this is for outbound rules. So from here now to specify if you want to do inbound rule and outbound rules, you do ingress. So this ingress now, you see from 22 to port 22. So this is how you specify it. Protocol is TCP. So in a Terraform, you don't really specify SSH. It will get SSH like the way you specify it on all of them. All of them are all TCP protocol. So you put the protocol TCP. Then CIDR block, you put the CIDR block there. HTTP as well. So these are all ingress. These are all ingress. Now egress. Egress. Whenever you see egress, egress is outbound rules. So ingress is inbound rules. Egress is outbound rules. You understand? So that one we saw outbound rules, egress. But you're not going to specify anything. This is how you specify it -1 because it's outbound. And yeah, it's kind of a lot to understand, but you get to it. So this is how you create security groups. So for your instance, you're going to create a security group that allows in 22 from anywhere, and then opens the port for the front end and the back end to be able to load. I'm sure you did it when you were doing this stuff manually. Now this is your real baby. This is your main baby, your main babe for this course, your EC2 instance. Now the resource, let me first of all go and check if this stuff is correct, because let me go and check this EC2. I want to go through the entire anatomy with you and ensure that everything, so that when you're watching the video, you then reading the documentation. This documentation is well. In fact, if you read the documentation, if you understand how to do your stuff manually, which is with ClickUps, and then you read the documentation, you do this thing in Terraform easily. So hold on, I want to get the AMI ID correctly. So now you can see when you're creating an EC2, you see AMI. AMI is this. This AMI, let me show you where you're going to get it from. This AMI, now let me show you where you're going to get it from. You're going to get it from here. This point in when you're deploying your EC2. I don't know why it has refused. This thing has refused to load. Now you can see this part where you say Ubuntu. This part where you say Ubuntu. We are using Ubuntu 22. This part here, you're seeing it. This is where you're going to get your AMI from. This is where you're going to get your AMI from. So you come here and then you paste it here. When you paste it, you now see instance type, var instance type. So this instance type now, to go and get a variable. So that's what the variable is. To come here, now there's a variable called instance type. You can see T2 micro, default T2 micro. So you come and pick it from here. The key name is this key that we created in the last class. Subnet security group. Now, this is security group that this instance
Sorry,
will
sir, we
assume.
can't see your screen. Can't see your screen.
Oh, sorry, I didn't switch. I didn't switch, sorry. Why? All right, yeah, confirm you can see my screen. So this is you're going to come here and you paste this is where you paste that AMI that you collected from there. You paste it here. So to go and use Ubuntu 22. Your instance type is a variable. So the variable will be from here, variable instance type. Then your key name will be this VPC security group ID. And this is security group ID now. The reason why you're putting it in a square bracket like this is because whatever it's assuming, so it's assuming multiple. So inside the security group now, there are multiple stuff inside, which is a multiple ingress, multiple outgress, multiple ingress, multiple egress. So you outline it in a square bracket. It's like an array type of stuff. So it's AWS underscore security underscore group dot ec2lg dot id, which is the ec2sg, which is this ec2sg dot id. Now subnet id is telling you where to put the subnet. It will go and put default AWS subnet default dot IDs. Now these IDs now you can see 0 here because even in a default in a default VPC there are multiple subnets. So this 0 now, like you mentioned when we did Python, when you're trying to get a particular number of a particular thing, you start from 0 for the first one. So this particular 0 now means you should look for the first subnet, which is US is 1, which is the one created in US is 1A. US is 1A. Yeah. So that's what it's looking for. So the very first subnet, that's where this one will be. We dump this EC2 instance. Now, user data is the script that installs whatever you want it to install inside. I would love us to use remote exec, but so now this is the whole Docker installation script that is supposed to install inside the EC2. So yeah, well, now you can see now. So you're going to call the user data out inside here, user data.sh, which is this. To call it out inside here. Now tags. This tag is going to say var.appname-server. So you're going to find where you have a variable called app name, append it here, -server. Let's look for variable app name. You can see Dream Vacation App. That's the app name. That means when you deploy this stuff, what you will see on your EC2 instances, Dream Vacation App server. So that's what you're going to see there. So that's it for EC2. So your assignment is basically everything here. Basically, the only difference is that you're going to create a VPC and subnet and CloudWatch by yourself using the documentation. But for all this is practically the same thing. Now, output. For EC2 instance, you want the instance ID. The ID of the EC2 instance is going to now Now, what this is going to do is, AWS instance dot during vacation app dot id. You can see here we have AWS instance dream vacation app. So it's going to pick the ID of whatever is created in this resource and output it for you. Public DNS, the same thing. Security group ID, the same thing. Key pair is this. Now to output the SSH command. And this SSH command now, it's going to put this Ubuntu at, is now going to give you the public IP that was outputted here. So you know you can just copy it and put on your terminal, basically. Now, variables. Variables is also another important point. You can see AWS region description. This was the description. Then the type of the variable is a string. The type is a string. You can see type is a string. Default. Now this default now is the variable that will be here by default. If you want to put it in the variable.ts. So this variable now is what will be here. US is 1. You can see it is in double quotes. US is 1. So anywhere someone refers to var.aws region, it's here that to come and pick US is 1. Same thing, variable instance type, but type string, default T2 micro. You can see it in double quote. This simply means that anywhere anybody puts var.instance type should come and what? Reference it here. I think it was here that it was this time referenced. Reference it here. Key name, the same thing. So this key name was created when I was trying to build the one with, you had to build the key, but I changed my mind. But it's still here. I changed my mind to use an existing key. But it's still the same concept. Now you can see this one is string, backend port. Now this port now you can see type number, default 3001 for the port. You can see now that this is number and this is not in any quotes because it's a number. You're going to treat it literally as a number. You get type number. So you have to specify this here. Front end number as well. So that's just how a basic Terraform this thing. Terraform. This is the basic of the basic Terraform code. So what you would do is write a VPC. Let's even go down to the documentation to see how you can create a VPC. I'm practically giving you cheat code right now. So tomorrow morning, that's my birthday. I send my account number. You will send appreciation. Anyways, let me. So this is the now to create a VPC, you come to resource AWS VPC. You get, you can do the cider block. Cider block is, let me show you. Let me go to VPC. Cider block. Now you can see create VPC. Now you can see this part where you put this part where I'm trying when people are creating it. When people are creating this stuff, you saw this part where you do VPC for cider. So that's what you're going to put here. Cider block, you put your cider block here. Instance tenancy, you're using default. That part where you can see this part here, default. So you can see that you can see the matching, why they call it infrastructure as code. So this is just for VPC. Now to create a subnet, so all the resources are here. Everything you want, they are here. Under VPC now, you will see EC2 subnets. EC2 subnets. Subnet. See subnet here. Now you can see subnets main VPC ID. This is the CIDR block. Now the CIDR block now for the subnets. Let me go back. So that's why I emphasize that you learn how to create it manually, because now you can see the VPC ID when you say create subnet. This VPC ID now, you go and reference that vpc.main that you created .id. Don't forget this .id. Oh. If you're using smart IDEs like Visual Studio Code, Cursor, and all those ones, once you click AWS VPC.main and you click dot, it will give you like a drop down of everything. You can choose .name, .id, different parameters, different attributes. But for this, we want just the ID. You get the ID is, if you check like this, if you're selecting this default now, you can see this sign here, VPC-OEE kini. So this is the ID. So whenever you are doing this, it will go and, when you get ID, it will go and pick up this value for you. You understand? Without even creating it. Now these tags now, see this tag is also very important, because it's these tags that will come out here. It's tags that will come out here. All these ones I have not tagged them, which is not good. All these ones that you see, private subnets, public subnet, you see them here. That's tags. So ensure that you tag your resources very well. You can do name equals to private subnet, because in the production environment, tagging is very important, because there are points where you need to identify certain resources by project or by name or by stuff. So yeah. So now this for subnet. Now after subnet, what's the next thing we're going to create? So you can see argument reference, kini region, availability zone. So all these ones are all these ones. This is basic usage. But there are also some reference that you can do if you want to create a subnet in an availability zone. If you want to add a CIDR block, if you want to enable DNS, just like what you have here. You understand? If you click on, let's say I want to click on this now, you can see all this availability zone, IP subnet, and the rest. They're all here. So that's what they call it, attribute reference. Map public IP on launch, true or false. You put it. Type on launch, VPC ID. So it's giving you a reference that you can, reference, basically. A reference that you can reference. Now, if you want to now create a route, this thing to create a route table as well. This is a resource to create a route table. Then there is route table. Create a route table. You can also create a route inside the route table. So inside the route table, you can do all those edit routes where you attach to an internet gateway. So you also need to create an internet gateway to look at it. You can create an internet gateway here. So everything should be part of your resources. So you can see internet gateway VPC main.vpc.id. So that means that's where you attach it inside. So you can go down and attach this internet gateway inside the VPC. There's a NAT gateway as well. If you want to create a NAT gateway, probably you're creating private resources. Create it, allocation. Now this allocation now is elastic IP that will be allocated to it. You put the elastic IP, you can put it in a particular subnet. So there are just a lot of things. So all you just need to do is think about what you want to create, and you can create it seamlessly. yeah, basically. So RDS, there's RDS here. So yeah, that's just it. There are a lot. But since we're not doing much, even the CloudWatch, I think the part of the task involves CloudWatch. There's CloudWatch, so you're gonna explore that part as well. CloudWatch metric alarm. You're going to do that. This is the end. Let me, like I said, in the spirit of giving expo, this is basically just what I wanted to do. Metric name, kini, threshold. This is what I wanted to do. So go and find out how you implement this for the EC2 instance that you are creating, because this is what is in the task. Me, I'm not a stingy person. No, I know that I'm not giving you, I'm not telling you people, I'm not giving you people cheat code. I'm just showing you people the direction on how to get the tax done. It's the smart ones now that will utilize it and get the tax done. So this is what you need. CloudWatch metrics, namespace EC2, everything. So you go and pick out the EC2 instance that you want to monitor and get it. So these are all the different CloudWatch for different EC2, different metrics and the rest for you, the consumption. So now there's also, apart from resources here, there's also there's also data sources. Now there's data sources and there's resources. Data sources is what we are doing. Understand? You can see data. So this data sources means that is when you are trying to get details about a specific resource that's probably already created. So that's what so if you check all these resources, you will see, if you're looking through all these resources, see now you're seeing VPC. You see VPC, you see the resources when you're creating it, then you see data sources for already existing. So if you want to also write code on already existing this thing, already existing PPC, you come to data sources instead of resources. I'm just teaching you how to find. Now let me show you registry modules. Let me show you how registry modules look like. You can see Terraform, AWS, VPC module. Now this is the Terraform. This is now. So in a situation where you're too lazy to start creating route table and all those you can just come and pick up a registry module. But this is when we start talking about modules itself. That's when you understand this better. So registry module is an already packaged and built together module that you just need to put your parameters, and it will use the models inside. It will use the models and then create the resource for you. However, this can be tricky, especially when you're working in an environment that is highly secure, because you don't know the underlying code that is used to create this module. You understand? So it's best that you know how to build this from scratch, all the networking and the rest. But sometimes you will not have time. Sometimes you just want to spin up something quick. That's when you use registry module. So this is how you do a module VPC. Next class we'll talk about modules, how we implement modules and stuff. You do the next one VPC, CIDR. So it gives you all this was already pre-built. You just put the name, put the tutorial slider, put the availability zone. If there are multiple availability zones you want to deploy, then you put it, put the private subnet, put the name, put everything, and then to just go and provision it for you, basically. So there are a lot of modules. Let's even do, I think there should be module for EC2. There are a lot. So this one is the one for VPC. So ideally, self, I would have suggested, but I want us to learn how to build it with all the routing and all those stuff. So let's see. This should be the one for EC2. So all the most of the resources, they have their own default module. And by one time I was trying to, when I was like getting gigs as EC2 instance, you can just impute the name, everything, and then boom, it would. There's multiple instance. You can just, it's already pre-built. It's like cake for you. Just pick it up, customize the cake. It's like when you buy cake, it's like buying cake in restaurants. This whole thing is like buying cake. Unlike going through the process where you have to, do the butter, the mixing, and the rest. This is just like buying cake from internet, from restaurants. Just, when you buy the cake, you write the person's name and give it to the person. So that's just what this is. All these modules are. So yeah, to Terraform is actually a very, very sweet setup. You understand? So let's go back to our code. Now, after you have, let me go back. I don't know if this will work. Well, I didn't take my time to debug it. I just wrote the one that I used to teach. But let's move forward. After you have written all what you have written, all has been said and done, you do Terraform plan. Now there's Terraform plan. Terraform plan is like looking into the architecture. Now, this Terraform plan now outline everything that you have created for you. It will outline everything that you have created for you. You can see, if you notice something, when you did Terraform plan, it will create terraform.tf state. Now, this you remember in the last class, we talked about TF state. TF state is the manifest. It's like a note that is outlining everything that will need to be created and not. So ideally, this Terraform state is in my local repository. That's why it's here. But ideally, see, it's not even going to ability to open it. Ideally, it's not even supposed to be here. It's supposed to be in a bucket, safe and sound. But let's just show you. Now you can see the AWS default VPC reading. It's reading means that it's going to get, this reading means it's going to get the VPC. Now you can see, if you check it, let's go back from the beginning. Now, the reason why this is telling you reading is because it's going to get the value of the default VPC. Now you can see read complete after 8 seconds. ID VPC OEE 2A kini. Let's go back. Let's go to VPC. You can see if you go to the VPC ID, look at it, 0EE 2DA 9CD blah blah blah. It has gone to pick the value from there. Subnet, we're going to pick the value US is 1. Now, Terraform uses Terraform power to generate you can see Terraform uses the execution plan. Now, the execution plan, Terraform will perform the following actions. Instance will be created. AMI is this. Now, this one will tell you known after applying. That means it's once you apply that you will know it. All these ones, they are like variables that You can only know when you apply them. The security group too. Now this ones you are seeing plus. Plus is for to be created. If you are modifying it to be dash, if you are deleting it to be red minus. So it has given you now the plan. The plan is 2 to add, 0 to change, 0 to destroy. Changes to output. It will give you the output to give you instance ID, key pair name, public DNS, private DNS. Now let's try Terraform apply. It may most likely fail, but now this Terraform apply. Now there are two ways. Either you do Terraform apply. When you run Terraform apply, when you do Terraform apply, it will run the plan again and then ask you a question. Do you want to continue with this application? You now choose yes or no. But me personally, I know that I want to apply. So when it asks me the question, I'll tell you no. Then I'll tell you the one that you do that you don't even need to ask you the question. Just go straight to apply. Now it's going to take time because it's something that is sensitive. So it's going to take a while. So you can see, do you want to perform these actions? Only yes will be accepted, but I'll put no first. Apply, cancel. So it's going to cancel the apply. But if I now do it again, I don't want it to now. You do dash dash auto dash approve. The reason why I'm teaching you this is because in your assignment, in your tasks, you are going to deploy Terraform using a CI/CD pipeline. So this is what you're going to put. So in your pipeline, you put Terraform apply. Now, if you put only Terraform apply, your pipeline will go and be waiting for you to do yes, and it will just be taking forever, then timeout. So on your pipeline, that's what you're going to do. You're going to do auto approve so that when it gets to that point in your pipeline, it will approve it immediately and it will continue. See, your pipeline shows green. That's the CI/CD is the reason why we're doing this is just for learning purposes, but deploying through a CI/CD is the most production effective way of deploying Terraform. You deploy it the same way you deploy code. So Terraform apply auto approve. It will run through the plan again and then automatically put yes and then continue. But let's see. I may not even debug it too, but let's see. Just want to show you how it looks like. So it's going to be pushing. So it's taking time. Now you can see change to this was the plan before. That it starts creating. This is how it looks like. It's going to do. You now start creating other resources. Other resources will line up under creating. Now you can see creation complete after 9 seconds. Let's go to secure group. You must not even wait for it to finish before you even start checking them out. Security groups. You can see it. Dream Vacation App SG. It has been created. It has been created. Oh, people are not seeing my screen. Hey, whoa, hold on. You can see here, Dream Vacation App SG. It has been created under the VPC. You can see it here. Dream Vacation App SG has been created. Now, let's go back to the code. Oh, okay. Actually, it actually even worked. Now you can see apply complete resource 2 added, 0 change, 0 destroyed. You can now see instance ID is this. So this is the instance ID. Let's go back to EC2. This is the simplest Terraform project you can do. Now, if you go back to EC2 instances, you will see. You can see Dream Vacation App Server. You can see it's running. It's not an initializer. You can see it's running. Let me show you time before you say that I've already done it before. You can see 20:01, which is 8 o'clock. 20:06, which is 8 o'clock. So yeah. So yeah, class cat, which is the class key, this thing that we created. Now, if you can see all the outputs. This is the public IP. The public IP, the output has a public IP. So if you open this now, you see public IP 100.26.193. 100.26.193, which is what is here on the terminal. Which is what is here on the terminal, 100.26.190.33. Now, if we copy this, now let's just say I copy this. I copy this as it is like this now. Let me copy it. Let me open a new terminal. CD downloads. The reason I meant to download because this is where my key file is, the other part of my key file. I now paste this. You can see, yes. Gang, I'm inside the server. You can see. I don't even know if that Docker installation worked, but let me check it. Do Docker. Yes. Okay, you can see. I did the Docker PS and it worked. I mean, the Docker was actually installed inside. Docker was installed inside. So yeah. So yeah, so yes, so all right. I'm done. So it's left for you to do what you gotta do for your tax. Any question of the day? Any question of the day? Why is nobody answering me? Teams, do you have a question? Am I audible? Wilfred, does anyone have question? Can anyone hear me? Please confirm you can hear me, so it's not be as if I'm talking to myself.
Yeah, we can hear you.
Yes, we can hear you.
Okay. Because people made me feel like as if I had talk to myself.
Good evening,
Any
sir.
question? So you can see how Terraform
Hello.
connects to your AWS and everything you deploy. So this is just a miniature You can deploy the most complex of code. So that's why we introduce version control, because this is also code as well, in as much as it's not, you're not writing logic. That's why it's always good to deploy. So it's practically the same thing. You understand? Deploy the same way, GitHub, workflows, Terraform.yaml, do all those jobs and everything. Then the first step will be plan. Next step will be kini. Then the next step will be apply, to go through those whole process again. Just the same way we did it manually here. That's how you deploy it.
So I have a question.
Gang gang. Gang 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 gang. Which one the IS wants to ask me question? Okay.
No, yes, you said we are going to be um automating everything using GitHub Actions.
Yes.
All right. So now because the one that you just ran now, there's no container running. You it's is it that you did not actually put any resources? You have not your app was not
No,
deployed
no,
with the
no. We
resources
didn't put
that you
any
created.
resource. So I didn't put. Now that's what I'm telling you. Now that's what you do. Once you have deployed this code now, and you have
Yes.
implemented that, you have implemented, you have used user data to install Docker, and then you
Yes.
run it on Terraform. Now, when you now run it on Terraform, that's where. So this is what will precede your. This is what will precede your application pipeline. So
Okay.
you have to ensure that this one works. So your pipeline should pass before that other one where you will do the arrow sync. You
Okay.
get. So
Okay.
this particular pipeline was what will, so you can do it in such a way that your, for example, now your Terraform.yaml will deploy finish. Then in the middle, you now have a deploy.yaml that will now check your Terraform.yaml if successful to now run the new one. You understand?
Okay. Sir, I don't understand the new one you're talking about. Now we have already
So
created all the resources, right?
yes,
So now
yes,
we now want to deploy the application on these resources that we
yes.
have actually
You
created.
there
So
are multiple ways. There are multiple ways you can go about it. One, you'd write your CI/CD pipeline to deploy that application should check if Terraform.yaml has successfully deployed, and extract the IP address from it.
okay. Okay.
Or you can write everything in one pipeline, but your Terraform pipeline, your Terraform step. So it can be,
Yeah.
when you write jobs, you see build, deploy,
Yeah.
all those things. You can write the first step, Terraform, that will do the Terraform deployment. Then
Yes, sir.
you now do build. The build now will need Terraform. You get.
Okay.
Then
Yeah.
the next one will be deploy. Deploy will now need build. So that deploy now will now get the IP address of Terraform, that EC2 that was created in Terraform. You can get the IP address. You can do like an extract to get the IP address. Same way we got the IP address from the output. You can also get the output too, and then embed it in your rsync that will move the Docker Compose to the EC2 instance.
Oh,
You
okay.
understand?
Yeah. Yeah. No,
Good.
yes.
Mm-hmm.
Thank you.
Be very careful, though, so that you'll not break code. But I know it's very possible you will do it. So yeah, any question? Now let's go back to one more thing before we close. This is where we're going to round up. Since we're not using, we are going to exit this now. We're out of the server now. Now let's go back. Now we have seen that everything's set and done, but we don't want to use this thing again. We want to destroy it. Please ensure that do not use destroy in production though. We're just using it for learning purposes. Terraform destroy dash dash auto approve. That's why it's an assignment. People will use your head to figure what is convenient for you. Now you can see Terraform destroy. To go through that whole plan again. However, you will see minus instead of plus because it's destroyed, not creating. So it is going to run.
So I have another question.
Oh, feel free, ask.
Right. So let's say for instance I have already created all the infrastructure that I actually needed, and I want to maybe delete or terminate maybe a particular, maybe the EC2. I don't want all the infrastructure to go down. I want to just destroy the EC2. Is there any way I can destroy the EC2?
Yes, you can. You can actually, but it will affect the state.
Not
But
through the
you can.
UI,
I've actually not
not through
explored
UI.
that. But no. You can do it. You can do it, but I've not explored it.
Okay.
I've not explored it, but you can do it. I know it's possible. I've not done it. I've not done that before.
Okay.
Mm. It's very possible. You can even just extract. You can even, but just that it will affect this. If you're not careful, it can affect the networking, especially if that resource. Sometimes they won't even allow you to do it because there's sometimes when that resource you want to delete. Now you can see now. Sorry to digress. You can see from this that run that plan again. However, you can see minus here because it's removing will be destroyed. So bam bam, you can see destroy complete, resource 2 destroyed. So if I go back to these instances now, I'll see. If I go back to almost see me, I don't go mess up. I went to go open company AWS. But anyway, sometimes these resources can just look too similar. So this is Dream Vacation App Server, yeah. Now you can see. If I go and refresh this, you can see this one is running, but if I refresh it, what will you see? You will see terminating. It's even telling you it does not exist because I already removed it. It's supposed to see terminating here. You can see now has terminated it because we have destroyed the infra. So yeah, that's just it. To be honest. Any more question? Any more question? So that being said, you have been given a premise for your tax. Please try and submit on time. For the person, I think this guy, the guy that complained about that did that job before, I don't know if he's in this class. But anyways, Isaac Adekule, I think I've remarked your submission and I sent it for promotion, so should be promoted soon.
Yes, sir. Thank you very much, sir.
No wahala. So anyways, that being said, I think I've done my best today. Tomorrow, people should show me love in that Discord server. If not, I'm going to cancel the rest of the class. But anyways, yeah, tomorrow is my birthday, like I said. I'm with my family, so I just want to sleep, to be honest. I just want to rest. I've been suffering. I've been attending to midnight calls with database issues and the rest. So, I need to rest. I took the week off and I need to rest. So I'm just doing this because I've stalled, I've delayed my classes for a while and it's as if we're all back. So that's why I'm teaching. If not, I've not even opened laptop since. I started just watching movies. But that being said, yeah, do your best, get those tasks done, and reach out if you need any help. Yeah, thank you very much for another Tuesday in the KodeCamp department.